Hello again. This video is on using definite integrals to solve DEs, and this is quite powerful. You won't think it at the start, but it is a very powerful way and a quick way to quickly get solutions for DEs, and even ones that can't be solved and things like that. We can use numerical methods. Anyway, I'll get into that later, and you can use your calculator to quickly solve DEs. And what it says is that if you have some DE that looks like this, dy dx equals f of x, and you know you're given some point, and also you're given that y equals, I'll just say a when x equals b. Okay, so you're given 2 points, okay, a and b. Haven't written that very well, but anyway, so you've got a DE and you've got your 2 points that you know. Then what we know is that y will be equal to the integral of f of x dx. But if you evaluate it at the point a, b, in other words, if you put b here and add a onto the end, and we have x here, then what you'll have, this is actually the solution, and it's already built in the constant of integration there. So you don't even need to go in and substitute values to find c and everything like that. It's already built into it, the fact that this point y equals a and x equals b is already built into it here. And so if you evaluate this, you'll get the answer straight away. And in fact, this is what your calculator does to find when it does DE solve and that sort of thing. So this is really, really powerful, and what it will give you is it will give you the y equals the function of x. That's the solution to this DE up here. So it's really good. Probably even better, that if you've got the same situation, dy dx is equal to fx, and you've got some other point a, b. I'll try it like that. No, it's the other way around. See, I just did that badly, so I'm sorry. And you've put the other point b, a. And you want to know, you want what y is equal to when x is equal to, let's say, some other point d or something like that. Then what you get is that what y is equal to when x is equal to d is the integral of fx dx, again, plus a, that's the y term there. We'll put the b term down here, and the value of the x that you want, we write that up here, and we evaluate this definite integral, and that will tell you the value of y when x is equal to d. And you can see it's the same format as up here. Up here we're just evaluating for some unknown x, for a variable x. Here we want to know what it's equal to when x is equal to d here. So this is really, really powerful. It probably doesn't make sense as it sits at the moment, but that's the general rule there. This one's just an application of that rule. So let me quickly run you through. Oops, what have I just done? I've minimized somehow. So here we go, just a quick example. Find the solution to dy dx equals sine x, given that y of 1 equals -3. Okay, something like that. Okay, so the solution will be, using what I just told you, the solution will be y equals the integral, and I'll just write sine x dx. And what we do, and I'll put little circles to show you what we do. There's a spot here and a spot here where you put two things. Here is where you put your x value. Okay, so what's your known x value? Your known x value is this 1 up here. So we write 1 there. That's your x value that we know, that given point. And what's the y value that we know is -3. So we write -3 up here. And we just want the solution to it. So we want it in terms of x. We're not looking for a specific point of y. So we just write our x up here. And that's all I'm going to show you today. I'm not going to evaluate this, but that's how we get the answer. And if you want to, you can just put that straight into CAS and get an answer, y equals blah blah blah. And that's a really quick way rather than mucking around with your constant of integration and substituting values back in, blah blah blah. A really quick way, and that's it. That's all I'm going to show you. I'll just do another quick example. Find the solution to dy dx. I'll just do something complicated just for the hell of it, because I'm not going to evaluate it. Just do this in the calculator if you want. Given that y equals 5 when x equals, log e2, something like that. Alright, let's go with that. So the solution is, again, y equals, it'll be the integral of e tan x dx. And let me just put our spots in again. This is the spot where your x value goes. This is the spot where your y value goes. Okay, your x's go on the integral, just like they always do. So let me write them in there. So what's your x value that you're given? You're given x is equal, and I didn't draw in a big enough circle, but anyway, get rid of that because it's not going to have space. So there's your x value. It's going to be log e2 down there for your x value. Your y value is positive 5, so there's going to be an add 5 on the end there. And then up here, what do we put? Well, if you wanted the general solution, in terms of x, you'd put an x there, but we don't. We actually, oh yes, we do. We do want that. We want the general solution, and so that would give it to you. Put it in your CAS calculator, and you'd get y equals something or other, and there's your answer. Okay, let me do what I was just thinking I was going to do and actually find a particular point. So, a couple more examples. Example, find the value of y when x equals 3 of dy dx equals the square root of x squared plus 3 given somehow given the coordinates -1, -10. Okay, so find the value of y when x is equal to 3 of this differential equation given this certain point. So in this one, we're not looking for a function of x, we're actually looking at substituting in x equals 3 at the end. So if you had to normally do this, you'd have to solve for y, and you get y as the integral of x squared plus 3 dx, and you get your answer, and your answer would have something plus c, and then you'd need to use that point to go and find what c equals, and then you write your solution out, blah blah blah, plus whatever c was, and then you'd have to substitute 3 into there. So then you start substituting 3 into there, plus c, and then you get your answer down there. So that was what you'd normally have to do. What this method is doing is a much faster way. You can just pop it straight into your calculator and be done with it. So really good way, and they will examine you on this. They love this, and so do I, with good reason. It's a really clever way of doing it. So y equals the integral of root x squared plus 3 dx, and let's think about what our spots are. Okay, we've got 3 spots. On the integral is where you put your x's, but let's just worry about which ones are the given points. Okay, so your given points, one here and one here, so bottom and to the right. And remember, x's go on the integral, so what's the x value that we're given? It's -1. So just get rid of those dots. So -1 down here. What's the y value that we're given? -10, sorry, -10. And what we do is we don't want x up here, okay, because we don't want a function of x as your answer. What we want to know is we want to know the value of y when x is equal to 3, and so we put 3 up there, and that will give you your answer. Into your calculator, bang, you get an answer, 7, whatever. It won't be 7, but I'm just as an example. There you go. I'll do one more just for the hell of it, but I think you'll probably get the idea. It's actually really simple once you've got it and you know what the spaces are. Okay, so find y when x is equal to -17 of dy dx equals x cubed plus 1, given that y 0, I'll do y, just do something a bit different, y1 equals 0. Okay, so what will it be? Y equals the integral of x cubed plus 1 dx. Let's chuck some values in. Okay, so down here is your x given. What were your given x? That's the 1 here. So there's a 1 goes there. That's the x value that you're given. What's the y value that you're given? It's 0. So there's a plus 0 there. You could just not bother writing that, but there you go. And we want to know what the value of y is when x is equal to negative 17. So up here, negative 17. Into your CAS calculator, bang, there you go. So that's really a good way of doing it. Check it out, give it a go. It's really important to this course.